Hello class, welcome to our lesson today dealing with the percent equation. This comes from section 6.4 in your textbook. In section 6.3 we went through the percent proportion, so I'm hoping that from the past couple days lessons that you're able to set up a proportion to solve percentage questions. Your other option is to use the percent equation. So we're going to go through that idea today and then also next class period to make sure that you have both ways figured out, and then you can kind of pick and choose which option you'd like to use more as you move forward in the semester. The first thing that we're going to look at is just a review of slope. So a few things to talk about slope to remember about it. Is first off, slope is using the letter m. Okay, so the letter m represents slope. Remember, slope is the change in y over change in x. That's steepness. That's how quickly the graph is going upward then at that point. It also could be written as rise over run. Now, there's a lot of ways to find this. If you have the formula for slope, you could use that. There's lots of ways to get it set up. One option might be a chart like this. Okay, so this is 4, 7, which is xy. So x is 4 and y is 7. X is 8 and y is 10. And then the change in y is just saying, well, what's the difference between them? So to get from 7 to 10 is plus 3, or 10 minus 7 is 3. 8 minus 4, or from 4 to 8 is 4. And so the slope here is just 3/4. So what that's saying is from the first point to the second point, I could go up 3 or over 4. Or if I was going backwards, down 3 and back 4. And the double negative would do the same thing. The second question has some negatives involved, so you just want to pay attention to that. X is -3, y is 4, x is -8, y is 9. And so for this situation, I'm starting with 4 and I go up to 9. So 4 plus 5, or 9 minus 4 is 5. And then the tricky thing is with negatives, make sure you know what you're looking at. You're starting at -3 and you're going to -8, which means you're going further down on a number line. Okay, so that should be a -5. And 5 divided by -5. Remember, anytime you divide out and you get an integer answer, you don't have to put the 1 on the bottom. So the slope here is -1 over 1, which would be, instead of going up 1 over 1, would be down 1 over 1 to the right. But when you're dealing with the answer, you could just write that as a -1 just by itself. Okay, there's a lot of information on these next two slides, a lot of different options. I just want to highlight a few things here. This is a pie chart. This says this is who's voted for a class election for different candidates, but so far only half the students have voted. First step is still the same as like a bar graph. Find the total. So if they give you a bunch of numbers, add them up and find the total, and the total here is 60. And then it says to figure out what percent, okay, based upon the number of votes this person got divided by the total. That's kind of like figure out your grade. So for example, Miguel got 9 out of the 60 votes. 9 out of 60, I'm saying, is 15%. You can do these percents in a lot of different ways. So let's look at Sue. Sue got 15 out of 60 votes. I could set that up 15 over 60, because part over whole equals percent over 100. I could cross multiply and solve that. For Leon, it's 24 out of 60. I could just simplify that down to 2/5, which is an easy percent to figure out. And you could also just divide it like I did for Hong, which is 12 divided by 60, which is 0.2, and then multiply by 100. All of these different methods can be used, and I think that's what sometimes students struggle with percentages, is knowing which option to use in which situation. If the denominator is not too bad of a number, you might want to deal with simplifying, but any of these options are good options. You got to make sure you show your work, though, in any of these situations. Okay, the next graph says this is the final results of the election. Now notice here I put total equals 120 now. That's based on the previous question. So in the previous question, it was half the students, and the total was 60. So I have to double that to get all the students, and now it's 120. The goal is to figure out how much each student got at a vote. Again, there's lots of ways to find this. Let's look at Hong, 25%. To find 25% of something, that's the same as 1/4. So I could do 1/4 of 120, which should just be a multiplication of 1/4 times 120, or 120 divided by 4. And then I get 30. For Sue and Miguel, they both got the same percent, so let's look at theirs together. I could do the percent proportion. I don't know how much I got. That's the part. Out of 120, that's the whole, equals 20%, which is given in the chart. And then cross multiply and solve, and you get 24. The third option, which many of you have known before, we just haven't done this yet in class, is to just take the percent as a decimal and then times the whole amount, and that will find the part. That's the percent equation, and this is the idea we're going to talk about over the next lesson and a half. Okay, so my total amount was 120 times the percentage as a decimal, and that will equal the total 42. Most likely the method you prefer is the one that's easiest for you. So some of you might find this one easier. The problem is with this one on the far left, if the fractions and decimals and percentages get more challenging, that becomes more difficult. The next group, okay, we've done percent proportion, so you're probably comfortable with that. The percent equation will probably be your option of choice long term just because it works well with decimals very quickly. But you need to understand kind of all three versions in order to be successful in the course. Okay, so here's what's happening. This starts with the percent proportion, or the definition of a percent. Part over whole equals percent. Now, when we set it up with the proportion, it was part over whole equals percent over 100. Okay, this is just saying whatever the percent is, it could be a fraction, number over 100, or a decimal, it doesn't matter. Essentially, all you're doing is multiplying the whole to the other side. Think of it like a solve an equation. If I want to get this part by itself, I have divide by the whole, so I have to multiply by that on both sides. So part equals percent times whole. That's the percent equation. Okay, so everyone needs to try the percent equation over the next couple lessons. I'm going to try to show both in a lot of my lesson planning because when it comes to the test, you'll have a little bit more flexibility. You should understand both still, okay, the percent proportion and equation. But for the homework today, I want you to try that percent equation, see if you can get an answer. Okay, so here's a good example of a style of question just to see the different ways that you can set something up. So what number is 55% of 80? Let's start with the far right one. A over 80 is 55 over 100. That one would be true because the part over the whole, part out of 80, is 55 out of 100. So this one definitely works. The first two are the percent equation. The word is important here. The word is in mathematics means equal to. Okay, so the word is means equal to, and the word of means multiply. So what number, I don't know, is equal to 55%, I make into a decimal, of times 80. That's what this first one is saying. And the second one's the exact same, except instead of 0.55, they made it a fraction, okay, 55 over 100, which simplified down to 11/20ths. Okay, so is equal to, of means multiply in these situations in mathematics. That leaves this third one, which makes no sense. It can't be the part times the whole equals the percent. It should be divide if it's going to be that way. 24 is 60% of what number? Again, the percent proportion is the one you're probably most familiar with. 24 is the part out of something. I don't know what it's out of. Okay, and that's one way to write it. And then that equals 60 over 100. The second one is the percent equation, Okay, 24 is equal to 60% of that number, and that's why it's 0.6 times that. Or similarly, the last one is 3/5 because that's 60 out of 100 as a simplified fraction. This third one makes no sense. 24 out of 60. Okay, 60 is the percent. Why would you divide by the percent in some of those situations? You can do that somewhat, but it can't just be 60. It's got to be something with 0.6, for example, or this 3/5, and kind of solve for x by multiplying by the reciprocal or dividing by 0.6. So if this 60 would have been different and made 0.6, then you might have an argument there that would work. But in its current format, that's not going to make sense. Okay, so here's a good example of knowing what you need for a test situation. You need to be able to do a percent proportion and a percent equation off of any situation. Okay, so for example here, 16 is what percent of 250? The proportion would be 16 is the part, 250 is the whole, x over 100. Cross multiply, 16 times 100 equals 250x, divide by 250. Look, this should be almost automatic at that point once you get going in that situation. Remember, this ends up being 0.064, okay, 0.064, you got to multiply by 100 to make it the percentage. For the equation, you just kind of read it literally. 16 is equal to percent unknown x times 250. To solve, you divide by 250. Now let's think about this. Grades are what many of you relate to this situation. Now I'm not saying this is a grade because that would be really bad. Okay, but 16 out of 250, okay, to find that you take 16 divided by 250, you get 0.064 times 100 to make it 6.4%. I showed both ways to be able to find it, and then I was able to find the decimal and then percent as appropriate. Okay, your homework today is section 6.4, numbers 4 through 9 and 32 through 36. Okay, I want you to show setups, show your work, and find an answer. Okay, I want you to pick a method, and especially on questions 4 through 8 or 4 through 9, and try those out. My recommendation is maybe do half and half. Maybe do some equation, some proportion, because on the test you're going to have to be able to do both at different times. So maybe you try the equation, try the proportion. One of the key things is making sure, like this one's already a percentage, okay, because you didn't have to worry about moving the decimal point. But if it was a decimal like this one, you got to make sure that you move it over to make the percentage on a situation like this one that's on the screen. Other than that, everyone needs to try those things out. Make sure you have your calculator, but show your work, show your setup. That's what we're looking for those questions. Have a good day, everyone.